So here we'll check how to check the model whether it is proper or not. So first we need to discuss about the sketch here. So what we are going to do here is we are going to check whether or what model we have created it is proper or not. So for that what we need to do is we need to go to the insert. So we need to go with the insert, then we need to go with the parametric analysis. Here in the tools toolbar you have to go with the parameterization analysis, then just click on this. Then we will check the model whether our model is proper or not. When you open that, you get a toolbar, you get a window like this. Here you can check all the sketches, and even you can check all the over constraint sketches, no over constraint sketches, then fully constrained. Only two sketches are fully constrained here, sketch number 1 and sketch number 2. Then we'll check under constraint. Sketch 3 is under constraint, sketch 4 is under constraint. Then next inconsistent sketches, no inconsistent. Then we take external reference. It is applicable when we do a remastering and all. Then root features also you can check. Yeah, we have a pocket command and a stiffener. So which are root features. Then we'll say isolated features. Then features in error, no errors in this feature. Then waiting for update, no updates. Feature with active stop, no. Then you can check bodies. Only one, we have only one body, that is part body. And all axis system. Only we have this absolute axis system. So now what we do is we go with the under constraint sketches and we'll troubleshoot it. Once again, I'll explain how to check whether 3D model is right or wrong. So first we need to check the sketch, go to the tools, then parameterization analysis. Then here you can check with the under constraint, fully constraint. So now what we do is we'll troubleshoot sketch 3 and sketch 4. Why it is under constraint? For that what I do, I'll hide this part body. I'll go to the sketch 3 first. Now I'll go with the toolbar, sketch toolbar. So in the toolbar, I'll go with this sketch solving status. Yes, when you see here under constraint, and what you need to do is you need to observe the figure. If you observe the figure, you can find here orange mark. Try to find the orange mark. Here is a orange mark. Yeah, so this point is not constrained. Even you can go here also, you can check. When you get under constraint, just click on this zoom. Once you click this point 12 is under constraint. So this is the issue. Except this point, everything is ISO constrained. So now we will troubleshoot with this. So either you can delete it. You can delete this point. If you delete this point, see, because this line has taken the reference of this and this. So we're not supposed to delete it. If I delete it again, I'll show you. Here you can delete this line. If you delete it, this line is the reference for these two lines, which he has taken as a here half, here half. This is a reference line. So instead of it, what I'll do is here, I'll go to the extend line. I'll extend this up to this point. If I extend, I'll extend like this. Now, if you see here, you will again get a 2 under constraint. Here what you need to remember is this reference line should be ended with the standard line. Here it should end, here it should end. So now what I'll do is I'll go to the quick trim and I erase this line and I erase this line. See, now our line is coincided with this line and this line. Now we won't get it. It is iso constraint. So we'll go with the next error, which is present in sketch 4. I'll double click here directly. Yeah, this stiffener is not constrained. Okay, so we'll troubleshoot this also. So why it is not constrained means here, let me take the part body, let me hide it. Here he has taken this projections, but not fully. Okay. So what I do here is, let me make coincidence with this. If you see here, see the size is increasing, right? It is moving here and there, but size is this circle size is changing, but this size is not changing. So let me fix this size first, then we'll check with the next. I'll give Control Z and I'll go to the sketch 4. First I'm going to fix this size. So now the size is fixed. Here also I'll fix its size. Okay. So now you can drag it. Again its size is changing because it is not at all its size is fixed. Now size is not changing, circle size. But circle location is not fixed and this location is not fixed. We need to fix the location. Now I'll give Control Z. Now I am going to fix the location also. I mean position. I'll just unhide the part body here and I'll fix it. So this reference line, and this circle center has the same centers. I'll take concentricity. If I take concentricity, now you can see it became green, right? So in the same way, let me unhide the pad here. So this one, so this line is coincided with this. So now also it is, see it became green. Now you can move this side and this side. It is moving. Why? Because this line is, it is vertically fixed, but it is not fixed horizontally. Sorry, horizontally it is moving, right? So it has to fix in a horizontal position, means we need to give the vertical position. Give Control Z. Now let me fix it. So from here to horizontal axis. Okay, already he has given. From this point to the vertical distance. See, now it got fixed. Now you can move it. It is not moving. Now you can check. It is still under constraint because as I mentioned, you should not have the endpoints. Either endpoints should be closed or else should be open. So here what I do is I'm going to close this endpoint using here only close arc. Click on the close arc, click this. Now you can check. It is iso constraint. So here the doubt is, so here he has not given, only he has given size, height and length. He has not given the reference axis, distance from reference axis. Here as you have to consider geometrical constraint. So geometrical constraints are nothing but the constraint between the geometries. Suppose we have one geometry here. So here can you see O, and this one is O and this one is O. O indicates that this is coincided. This coincide and this coincide. Now this is coincided with the 3D body. So first this line is coincided with this line. Then this line is coincided with this line, and this line is coincided with this line. So here I have given the geometrical constraint, not dimensional constraint. So this is dimension. So I have given here dimensions, and here the rest of the things for the location I have fixed it. I have coincided this and this. So basically we have two things, dimensional and geometrical geometrical constraints.